I think it's time that we start today's webinar from IEA and from ANAND. I am Xiaojing Guo from Tsinghua University, Beijing in China. And today it's our honor to have Mr. Li Jianghai Li as our speaker. Actually, this is the first ANAND webinar to celebrate our 20 years anniversary. So first, we would like to invite an officer from IEA, Helena, to give our to say something for us as a welcome speech. Thank you.
Thank you, Xiaojing. Ladies and gentlemen, dear colleagues, greetings from Vienna and welcome to the ANAND webinar series for 2023. These webinars are jointly organized by the Steering Committee of ANAND, the Asian Network for Education in Nuclear Technology. I would like to say that this is a great example of regional cooperation, as we will have lecturers from different Asian countries for these webinars. And this is a good example of cooperation with IAEA as the agency facilitates this webinar series. And this is a good example of interregional sharing of knowledge as facilitated by the IAEA and partner education networks from Africa, Latin America, Europe, Asia, Eastern Europe, and Central Asia are participating as observers in this event. Collaboration within and among educational networks contributes to the promotion, management, and preservation of nuclear knowledge and helps to ensure that talented and qualified human resources are available for the safe and sustainable use of nuclear technology. We want you to broaden your perspective on many issues related to the peaceful uses of nuclear technology, from energy and sustainability to safety and security. I wish you good luck with the great initiative from ANAND, which aims to enhance cooperation and knowledge sharing among nuclear professionals in Asia-Pacific region. Let us work together towards a bright and more sustainable future for all. Thank you. And I would like to hand over to Xiaojing, please.
Thank you very much, Helena. Actually, this year, we will have about 10 webinars, and we look forward to receive all kinds of nuclear knowledges from all over Asia, okay, in Asia area.
This is excellent.
Thank you. Now, I would like to hand over the presentation to Mr. Li, and we can start our webinar now. And the topic will be about computer security, and it will be mainly about we will also introduce the computer security work in China, in HTR.
Yes. So hello everyone. Can you see the slides? Can you hear me?
Yes, everything is good. We can see. Yes.
Yeah. Thank you, Helena. So hello everyone. This is Li Jianghai from Tsinghua University, the INET Institute of Nuclear and New Energy Technology. And today it's my honor to be invited by the INET to give the webinar, give a talk in the first webinar of this year. So yeah, thank you, Helena, thank you, Ms. Guo, about the invitation. My topic is about the computer security of nuclear power plants. Okay, let's go to the next slide. Okay, yeah. Here's the outline. First, I will talk about the computer security risk in the nuclear power plants and show the real events in the history and how the nations and organizations respond to these risks. Second, I will analyze the computer security problem and show what makes this issue special. Then I will show our work, the Tsinghua University INET's work on this issue. After the above three parts will take like 45 minutes, and the remaining time will be the question and answer session. So first, our university is like the top universities in China. We have multiple department, institute in our university. And our institute, the INET, is one institute among those departments. So our institute is located in Beijing, and I'm with Ms. Guo from Beijing of China. And this institute is founded in 1960s. And our institute have several research areas. First, the advanced nuclear energy. We got 3 research reactors in our Changping site. One is the twin core experimental shielding reactor and a 5 megawatts nuclear heating reactor, and the 10 megawatts, the high temperature gas cool reactor, HTR-10. That is our primary research area. And also we have several nuclear applications about the container inspection system and the new energy, like the battery, the fuel cells, and also we have several professors on the energy policy. So that is basically the situation of our institute. And our institutes are now designing the new type of generation 4th reactor, the HTR reactor, high temperature gas cool reactor. As I mentioned, we have built the HTR-10, a research reactor in our Changping site of Tsinghua University. So that is the first one, and also we have designed the HTR-PM, the Pepper module reactor, which is the commercial reactor that has a 2 NSSS module, the nuclear steam generator, the steam supply module, and 2 modules to drive 1 turbine, and it can generate the electricity of 200 megawatts. And what we are now designing on is the HTR-PM 600, which has a 6 module to drive 1 turbine. And here's the main control room of this 6 module. So the operator monitor and control 6 modules in 1 single room. So that's also the big challenge. But today I will talk about the computer security of the NPPs. So let's imagine the following situation, following scenarios. If this happened, what can we do? The first is some anti-nuclear hackers take control of the NPP's instrumentation and control systems and claim to cause the radioactive release accident. So if this happened, what can we do? And second, some organized criminals steal highly sensitive data from the NPP's business network and hold it for ransom. So how we can deal with that? Do we have to pay the money, or how we can retrieve this data? And the third is some cyber terrorists shut down the physical security systems in order to steal this nuclear material for some, maybe the dirty bomb. So what we can do with that? So these are the risks of the computer security of the NPPs, but these are not imaginary risk. This is a quote by the IEA former Director General Armano. He said in 2016, the year of 2016, he said this is not an imaginary risk. This issue of cyber attacks on nuclear-related facilities or activities should be taken very seriously. So why he said that? Because there are several incidents happened in the history. So I will show some. So the well-known incident is called Stuxnet, which happened in like 11, 12 years ago, or maybe 14 years ago, is in Iran. In 2009, some enrichment plants has found hundreds of centrifuge equipment were damaged in benches, and people don't know why. And there is no signs of man-made sabotage. It is unsolved case. And a year later, Computer Security Corporation, the Symantec Corporation, discovered a new unknown virus on the internet. They named it the Stuxnet. And after the researchers doing the research into the virus, they found something unusual. First, this is a very cleverly crafted virus, but it seems has no consequences, and it's the designer want to control its spread. It's not like other virus spread everywhere. It may kill itself like in 5 hops. And also it's contain multiple 0 days vulnerability. You know, the 0 day vulnerability is quite expensive. It's like millions of dollars in the market. And but this single virus contain multiple 0 day vulnerabilities. But so people are puzzled. Why the designer want to design such a virus? And after that, some reporter say that the Stuxnet malware is the cause of the damage to the centrifuge equipment in Iran. So a large number of centrifuges were destroyed, resulting in the delay of Iran's nuclear program. And the Stuxnet was the first demonstration that the cyber attacks can destroy the physical systems. So people never thought of it before. And here is some details of how the Stuxnet work. It is very, very clever. So the attacker exploits the Windows vulnerabilities to inject the malicious code using a portable media, maybe a USB disk, and also it exploits the vulnerability to attack the Siemens, the very famous control equipment, vendor and using its software, the WinCC. So attack the Siemens WinCC server and replace the project files. And also it tampered with the PLC program and modify this system set point much higher than normal. So this results in the equipment damage. That is one thing. And the other thing is it's before that it records some normal value, and during the attack, the virus replayed this pre-recorded normal value to the monitoring system to prevent the alarms to the operators. So operators sitting in the main control room and see everything's fine, everything's normal. They are not aware. They were not aware of what were happening in the field. So that is how the Stuxnet destroy this physical equipment. And yeah, so here's the incident in the history, very famous one. And also, in fact, before that, before the year 2009, there was also the quite famous test reported by CNN. It is called the Aurora generator test. So the researchers launched an experimental cyber attack to cause a generator to self-destruct. The same attack scenario could be used against a huge generator that produced the country's electricity power. So this experimental was conducted in March 2007 at the Department of Energy, the Idaho National Lab in US. So in the video that the CNN obtained, it shows the generator shakes and spokes and then stops. So this video is by the CNN, and I can show you. You will see. So it is said that the reporter spent 6 weeks to find the vulnerability of the control software of this generator, and also write some malicious script and inject it into the control system of this generator and finally destroy it. So that is an experimental attack. And also there are many public known attacks against the MPPs. For example, in Japan, 2014, there was a malware-based attack, in fact, the system in the reactor control room. And also in the South Korea, 2014, the attacker have stolen also the data from the system. And also in Germany, 2016, the MPP in Germany, a computer virus was discovered in MPP systems. So, and here is a list of the cyber incident at the nuclear facility. This is from the report by the NTI, the Nuclear Threat Initiative, and it lists 23 events, 23 incidents start in the year of 1990 to the year of 2016, and some of the incidents are just accidental, maybe some accidental virus affect the system, computer-based system, but some of them are intentional. And also some of them are unknown. People don't have the evidence whether it is intentional or accidental. So from the list we can know the cyber risk is not an imaginary risk. It's already happened. The cyber events are already happened in this area. So the people, the nations, and the international organizations are also very concerned about this risk. So they produce many the regulation guidance, as well as some laws, standards against this computer security. So from the IEA published some documents on the nuclear security series. Here's you can see the red one, the NSS 42-G and NSS 17-T and the 33-T. They are related with the computer security. So the 42-G, the title is Computer Security for Nuclear Security, because this is published by the Division of the Nuclear Safety and the Security Department. And also the NSS 17-T, the Computer Security Techniques for Nuclear Facilities, which just published the version 1 just published 2 years ago. And also the NSS 33-T, the computer security of the instrumentation and control, the I&C systems at nuclear facilities. And also there's another document by the Department of the Nuclear Energy. They are published some in the computer security aspect of design for the I&C system at nuclear power plants. So that is the IAEA's publications. So you can download these from the website, from the IAEA's homepage. And they are very useful. Many experts have contributed a lot of effort on these publications. And also the US approach, US government also did a lot of things. In 2010, the US NRC, Nuclear Regulatory Commission, they published the RG 5.71. So the main content of this regulatory guide is it emphasize the functions related with SSEP as safety, security, and emergency preparedness. And also it emphasize how to maintain cybersecurity program. So that is the RG 5.71, and also in the year of 2017, the Idaho National Lab, Bob Anderson and his colleagues also published the report named Cyber Informed Engineering, the CIE. And also the last year, I see the news that the DOE, Department of Energy of the US, has required every, not just the nuclear area, but all the energy industry have to adopt this methodology of cyber-informed engineering. So great work. And also China has some the approach against this cyber risk. First, we have a cybersecurity law, the national cybersecurity law, and also we have the multiple level protection scheme 2.0. So the first version is just for the IT system, but the second version it also proposes the requirement not just for the IT system, but also for the industrial control systems, the cloud plants, the IoT, and other kinds of computer-based systems. So you can, if you are interested, you can search the report at the bottom of this page. And also in the nuclear area, the CAEA and China's NRC also published the NPP's cybersecurity technology policy, which are in Chinese. But the main content, I think, is we are all the operators, the institutes, the nuclear institute are now working on this policy, and we are find a way to implement into the plans. So that is China's approach, and also the International Standardization Organization, the IEC, also made many contributions to this problem. So the IEC they used to has the categories of the NPP's INC system. For example, they have a category A, B, and C of the INC system. The important to the safety, and they also published the standard called IEC 62645. That is the requirements for the security programs of the computer-based systems. So that is how we can maintain and this cybersecurity program, especially for the INC systems. And also it has the IEC 62859 called the requirements for coordinating the safety and security. So the basic idea is safety first. So any cybersecurity measures cannot interference the safety. So nuclear safety first. And also these figures are old versions. So in fact, this IEC 63096 has already published. It's this list, like 200 pages about the security controls for these INC systems. We also, our also involved in the drafting these standards. And also currently there was like two technical reports are undergoing. One is led by the Mike Rowland in US about the risk management, and also another report led by Vitaly from Russia about the system modeling, system architecture modeling. So there are just in the maybe this year or next year, you can see the technical report on these two topics. So that is the first part. And the second part is about the special aspects of the computer security issues. So why computer security become the hot topic these years? why we didn't mention it like 20 years ago. Because this due to the current trend of digitalization of the MPP systems. Historically, the MPP were vulnerable to cyber attack. Why? Because we are using the hardwired or analog implementation of this the system, the control systems or others. And also some MPPs contain some small amount of the computer systems, and we also using the designs philosophy of segregation, independence, or redundancy, and diversity. So, for example, the safety INC systems usually require different digital implementations. The original intention is to avoid common cause failures, the CCF, common cause failures, and improve the reliabilities. But also, this diverse design can also increase the difficulty of the adversary's cyber attack. The attackers need to learn about like at least 2 types of systems, computer systems. So that is the situation in the history. But nowadays, there is a transition from analog techniques to the digital techniques. So we have we are using the digital reprogrammable devices like the PLC, the programmable logic devices, controllers, and also the functional interdependent stations like the DCS, the distributed control systems, and also the extensive interconnected system like the SCADA system, SCADA, SCADA systems. So this digitalization makes the system more precise, more reliable, and easy to maintain. So this system becomes more friendly to the legal user, but on the other hand, it also becomes friendly to the illegal adversaries. So that is the digitalization introduce this new risk of computer security into the MPP. So the malicious attack could have a serious effect on the plant safety, even on the nuclear safety. And also, if the cyber attack interrupts the electricity production, it can lead to the economic and society losses. So these 2 figures will show you the transition from the analog techniques to the digital techniques. So the left figure is the main control room of the European power plants built in the last century in Norway. In fact, you can see there are dozens of instruments on the console panels. It is difficult for the operator to monitor these parameters. It's also difficult for the engineers to calibrate these instruments. The right picture is the main control room of HTR-PM that is designed by our institute. The operator can control the valves, the pumps of all around our HTR-PM. And through this keyboard and mouse, and from via these display screens of the computer operator station. So the total number of the inputs and outputs is over 20,000. So the nature of the computer security is not the incremental improvement. It is the gaming and confrontation. So for reliability, we can say we can improve the reliability step by step. Like we can say the 99%, the 99.9%. But for security, we can't say that. We can't say 99% secure. It is not possible because it is a game between the threat agent with the defenders. So the threat agent, or we call it the adversaries, do not randomly pick the 1% weakness. No, they don't do that. They just exploit your vulnerability with intentions. So we conclude that the safety measures are against the random failures, but the security measures are not. They are against the intentional attacks. So this cyber attack is a new dimensional threat. So compared with the traditional threat, like the intruder, with guns, with knives, with guns, they threat this MPP through the physical way. But the cyber threats can do it in a digital way. So people usually say we 3G to protect this MPP. We have a gate, we have a guard, we have guns. But now we need geeks. We need the computer experts to protect our MPP. So this new dimensional threat also bring the new challenges. First, it has a serious consequences. These consequences are not limited to the cyberspace. It can lead to physical damage. We have talked about that before. And also the attack is covert. It is difficult to detect the attacks, and this can be more difficult to trace the adversaries, because the adversary may just hundreds of miles away. It can attack the MPP remotely. And the third is this malware, this weapon, this cyber weapon are easy to access. You can just download the malware from the internet. The malware, it is maybe difficult to get the gun, but it is quite easy to get some malwares. So I will show you the cover of the scientific fictional novel called Flatland, and in this picture, in this figure, there was two-dimensional creatures in the flatland. They built a castle that seems well protected. It has a thick wall, it has 2 gates, and several separated rooms. It seems solid and cannot be intruded by others. But however, as a creature in 3-dimensional spaceland, we can easily enter the room from the above. So which is unaware of the 2-dimensional creatures. They don't know about the new dimension of above or below. So this cover show exactly about the new type of threat, the cyber threat. If we just protect the facility with the physical means, physical ways, we have a big risk. So why this computer security of MPP important? I will use a slide from the Mitch Hughes, an officer from the IEA, and during his talk, I think this slide is great. it gave a clear presentation of the new scope of the computer attack to the MPP systems. So the adversary are not only compromise the traditional CIA, the confidentiality, integrity, and availability of 3 features of the digital assets, no, but also they may affect the system functions. So the in IEA publication, it lists 4 consequences of the system compromised. So the shutdown of the system, usually we think shutdown is the most serious one, but no, the shutdown of the system it's maybe just the second one, but the compromised INC system could perform unexpected behaviors and without any failures. More serious, it can cause this unexpected behavior and the operator doesn't know. So it shows nothing to the human operators. So the whole MPPs are in the unknown state. It's just like what happened in the Stuxnet incident. And why this computer security of nuclear power plants difficult? Because the objective is different from the traditional computer security. So the traditional computer security of IT system usually have as we mentioned, the 3 objectives. The CIA. So confidentiality is the first priority. But for the system, INC system in the MPP, the availability, the integrity are more important. So the traditional IT measures cannot apply to this MPP system directly. I can show you that, for example, usually we use the antivirus software. If we use this software in a context of INC system, it may affect the real-time nature of the system. And also the ordinary IT firewalls, it cannot resolve the industrial protocols like the OPC UA, the Modbus TCP, or the Siemens S7 protocols. And also the software updates to fix the vulnerability of the system may cause a control system reboots, which cannot accept by this MPP. So here's a list to show the main differences between the IT systems and the INC systems. The time-critical content, the IT system can generally delays can be accepted. For example, if you open the web page, you can wait for like several seconds. But for the INC system, no, it must be respond in milliseconds. And also the network protocol, usually the successful of the internet is everyone adopt the TCP/IP protocols. So we talk in the same language, but the INC system, it has a virus of control protocols, as I mentioned, the OPC UA, Modbus, S7, the Profinet, a lot of protocols. And also the availability requirements, IT system can tolerate the interrupt and restart. You can restart your computer after it updates the operating systems, but the INC system should be online 24 hours a day, 7 days a week, 365 a year. So that is the context is totally different. So what is the state of art? What is the current situation? The current state status is most MPPs depend on the physical isolation, or what we call air gap. But first, the air gap is not feasible because there is a trend now that more and more industrial control systems are interconnected. For example, we have some intelligent, the computerized procedure system, intelligent alarming systems. They are all connected with the traditional INC systems. So, and the second, the air gap is not enough. There's many ways to cross this air gap. For example, you're in the develop phase, there is a supply chain risk. You can imagine if the MPP receive the keyboard or the mouse that contains some malware or malicious components in it, and it will bring the risk of cybersecurity. And also during the operational phase, there is the insider can compromise these computer systems, and also in the maintenance phase, the portable devices, for example, the maintenance laptop can be the vector for these attacks. Sorry. So the MPP security from the cyber physical perspective. This is what we are looking at, this problem, this MPP security, cybersecurity problem. There is a concept of cyber physical system, the CPS. So the CPS is a bridge to link the cyberspace with the physical world. So the digital MPP system is a type of CPS. It connects the cyberspace, for example, the embedded controller software with control logics, the real-time server software with I/O tags, the human machine interface software with operating means, the communication modules with TCP/IP protocols. So there are the elements in the cyberspace, and also there are many elements in the physical world, like the sensors, the actuators, the process, the nuclear process, the electrical generation process. So the digital system, INC system, link these few spaces together. So the cyber security of this system is the cyber attack cause physical damage. The cyber security causes leads to nuclear safety and nuclear security consequences. So if we see this system in the CPS cyber physical way, we can have we can consider this situation from both cyber side as well as the physical side. So that is what we have done and what we are doing on this issue. So as an research institute, our research is under this PDR framework, prevention, detection, and response. So the prevention is we study some cybersecurity programs, and we also study the cyber risk assessment. And for the detection, we study the attack modeling and analysis. And also, we are using some machine learning algorithms to do the anomaly detection. And during the in the response part, we did some work on the cyber incident response plan. Because today there's not enough time, we don't talk about that one by one. We just pick up some most important part. So here is what we have done. We propose a 3-level cyber capability threat model. So we classify these threat agents or hackers into 3 groups. The IT hackers, ICS, the industrial control system hackers, and MPP hackers. So the IT hackers are skilled with IT security, but they are not aware of INC. And the ICS hacker, they are skilled with IT security as well as the ICS systems, but they may not know about the MPP process. And for the MPP hackers, they know everything. They can access the information about the MPP. So the attack launched by these hackers, these 3 groups of hackers can be different. The IT hacker, they usually just remain in the cyberspace. ICS hacker, they may affect this INC system itself. And MPP hacker, they can go through this digital INC system into the physical world. So here is some scenarios, example scenarios we proposed. For the IT hacker, they can launch the denial of service attack, which will block the operator's access to the PLC from the HMI. And the ICS hacker, they can launch this packet injection attack. It can forge a packet to shut down the running PLCs. And the most serious one is by the MPP hacker. They can launch the attack called feedback spoofing. It can spoof the process feedback data to mislead these operators. So I will show you a video about the 3 attacks we are now doing. So here is the PLC kit we built. Sorry, I start again. And here is the you can see Siemens PLC S7 300 and the a touch pad, and there's a switch behind. And also we have a small computer containing some malicious scripts. And the control system is quite simple. It shows we want to control this water level between 2 meters to 8 meters. When it is above 8 meters, we can start the valve. And when it's below, we can start the pump. And when it is over this 8, there's alarm, the high alarm, and also there will be a low alarm when it's below 2. And this is the first DOS attack. And you can see after this attack is launched, and the operator have nothing to do with the buttons. The buttons cannot have any response. And the second one is malicious packet injection. And we can send the stop command to the PLC. So the PLC, you can see it used to be green light, but now it turned to yellow, means the PLC, the controller is offline. So in the first scenario, the PLC is online, just the operator loses the view of the control loop. But in the second one, the control loop is lost. And the third one is the most serious ones can only be attacked by the MPP hackers. So when this attack is launched, it seems everything is normal. Nothing, the operator can control the pump, the valve, but you can see closely if the operator open the valve, the water level will going down. And in the real world, it's already below 2, but on the screen it remained to 2 because that attack just spoof this feedback, the water level feedback from the PLC to the operator HMI. So that is 3 attacks we demonstrate to show our threat model. And also we also did something using the machine learning algorithms to detect anomalies in RNC systems. And I can't show the whole process. I just pick up the most important, the feature extraction. So we capture the data packet from the RNC network switch, and we can extract the features from the data packet. We classify them into 3 groups. One is the cyber features. It contains the time of the packet, the length of the packet, the address of the source, IP, the destination, and IP, and also the ports of those things. And also we can have the ICS features. It can contain the types of protocols, the function codes, and the address of registers, operating values. And also we can get if we know the information of the configuration files, we can also resume this process data like the water level, pump speed, valve control command, and the nuclear power set point from the packet. So we can have a deep packet inspection of these features, and by doing this, we can detect the anomaly from different level of the RNC systems. And next, I will talk about some international cooperations between our university institute with the IAEA. So we are involved in this IAEA CRP coordinated research program, J6008, and it's on the cybersecurity. The name is Enhancing the Computer Security Incident Response at the Nuclear Facilities. So the goals of these CRPs to develop a model or simulator of the hypothetical pressure water reactor to allow for research testing of the effect of cyber attacks. So and real control equipment can be interfaces into this model, and also the threat model or threat scenarios can be developed by our group, the CRP group, and also the computer security measures to prevent and protect against these cyber attacks will be developed. So this is a big project. There are 13 countries, 17 institutes are involved in this CRP. So you can see from many countries, and our institute, our university, Tsinghua University, is representing China to join this CRP. And here is what our part, the China's part. We are now our objective is develop the main control room operator console of this architecture, and also we did some research on this part. As I know, the the final report of this CRP will be published maybe at the maybe several months later. So the IEA officers, Ronnie, are working on this report. And we host the IEA technical visit to Tsinghua University, to our institute.net. And in the January 2019, so the researchers paid a visit to our HTR10 reactor, and also we developed something for the interconnections between the different parties. And here is some prototype we proposed and built for this IEA demonstration and CRP. So this is what we call the reconfigurable cyber security platform. So it has 3 parts. In the middle is the MPP simulators. So it is the hardware in the loop simulation. It contains the PLC kit, which is containing some physical hardwares, as I mentioned, showed in this video, the Siemens HMI, Siemens PLC, and also the simulator. And also it contains the MPP box. The São Paulo University in Brazil, they built the Ashera nuclear simulator. And also we, Tsinghua University, contribute the main control room operator console. And all of this can be as the MPP simulator. And on the left side, there is an attack generator. It can generate the attack I mentioned before. And also it can generate like hundreds different variants of these attacks. And on the right side, there is what we are now developing, the cybersecurity measures. It has the different level IDS, what we call the OT IDS, operating technology. It is not the traditional IT IDS. It can resolve the different industrial protocols, and also they will transmit the data to this what we call the OT SOC, the Security Operating Center. So we can detect the anomalies by this OT SOC. And here's some pictures for the MPP box. So the whole plant can be simulated in this such a small types of small the workstation. And also we built the HMI figures for this main control room. And here's the PLC kit, which integrates the hardware, so we can attack this hardware, and also the attack generators. We can using the Python scripts to generate different types of attacks. And also we built what I mentioned, the OT IDS. We based on some open sources software, the 3GADA, and develop some new rules into this software, and then it can analyze the Modbus, the OPC UA, these kind of protocols. And also we, based on another open source software called Greylog, we can implement the OT SIM. So by these softwares. And so here's the summary of the Tsinhua's INET work on the computer security of MPPs. We did some research, the overall framework of PDR, the threat modeling based on capacity, anomaly detection using machine learning, risk assessment. I didn't mention it today. And also we developed some prototypes, the PLC kit, the reconfigurable testbed and OT IDS and OT SIM. Also, we apply our methods or the techniques into the real project. For example, the HTR project we are now working on, and also we did some risk assessment for the facilities, as well as for some RNC equipment. And we also support the exercise and trainings by the Chinese nuclear security centers, and the international cooperation, including the IAEA, CRP I mentioned, and also in the next month there is a big conference called Cybercom 23. And we were representing China to do the state-level demonstration. And we're also involved in the training course development for the IEA. And also the IEC, we are involved in the standard development on the RNC security, and also the technical report on the risk assessment. So that is my talk on this computer security of nuclear power plants. So thank you for your time, and we can go to the Q&A session.
Okay, thank you. Thank you, Professor Lee, for your excellent presentation. And next, we would like our audiences, our listeners, to ask questions, if you have any. 现在退出共享。
对，退出了，就点这个。
点这儿就可以了。
对，就点这个，就是他们问问题。
You can also post your questions in the chat box area. 感觉这种可能不一定有太多问题，所以我们可以说他可以发邮件或者怎样。
Yeah.
你的邮件刚刚留了吗
Yeah. Yeah, you can.
More Could you please give more information about tech visit? Tech visit to where? Tech visit.
Yeah. So yeah, there's a tech visit. So that is in fact the CRP. I can provide you more information about this CRP. So the CRP started in 2016 or 17, and it lasted 3 years. In fact, it lasted like 4 years because there was a lot of work to do. And during these 4 years, we have we host several conferences. The meetings, we usually meet every quarter, every 3 months, and we talk. We have a teleconference once every other week, and also we have the technical meeting in the Germany, Erlangen, in Canada, Bruce Power, they host one, and also our university, Tsinghua University, we host one, and the last one would be in USP, the São Paulo University, but unfortunately there was a COVID since, so it is cancelled. It was cancelled. So yeah, and it is. I think it's a very good opportunity to join this CRP and to discuss the same. We have the same interest. We discuss the issues with the colleagues is wonderful. Yeah. So, Ali.
The second question. If hardware is physically isolated from the outer world, then how they can be remotely hacked? Like if there's no internet, Wi-Fi, or Bluetooth attached to them, is it possible?
So I can give you a scenario. Very good question. Many people are this is the first question for the people know about the computer security of the isolated network. So as I mentioned, for example, in the incident of Stuxnet, the control system of the Iran's nuclear facility is also isolated. It's isolated from the outer world. It's isolated from the internet. But people can use the USB to transfer this malware into the network, and it can attack the system automatically, or it also can be remotely. Why? If there's an insider into entering this MPP, the insider could be maybe some cleanser that some adversary pay a lot of money to the cleanser, and he or she will just maybe drop their cell phone besides this switch. And he plug in some receiver into the switch, and then this isolated system become connected to the internet. So there's many ways. It's usually designed to be isolated, but in fact, in the real world, it can be easily connected to the network, to the internet. So.
Okay. The next question.
Christopher.
Yeah. Good afternoon, Christopher. I noticed in your presentation that you use open source software. Why do you use open source software?
Because open source software it's easy to do the secondary development, and if we develop from the beginning, we don't have enough resources to do that. So that's why and also because we are an institute, we want to show the student, we want to teach the student. So the open source software is with no that's no licensing and commercial license. So it's will be suitable. Yeah.
Thank you. Analog and digital efficiency. So do you want to compare the efficiency between analog and digital?
Okay. Yeah. It's currently everything is digital. So in the newly built MPP in China are all digital. The whole plant is digital one. The digital control system, the digital physical protection system, everything is digital. And also there's some old MPP, they are doing digitalization modification. So they transfer the analog component to digital. So the digital is the trend.
Okay, let's look at the next question. Would you please give me more information on the national system of cybersecurity of NPP in China? Is there any government authority in China handling cybersecurity issues in relation with operation of MPPs?
Yes, very good question. Yeah, we have multiple national authorities to handle this problem, handle this issue. So we have the national the China's NRC, which they are more focusing on the safety things. They are worried about how the cyber attacks can affect this nuclear safety, and also there's the agency about the nuclear security. They are worried about the cyber attack can compromise the physical protection systems, and also the Department of the Energy. They are worried about the cyber attacks disrupt this power generation, and also the public security agency. They are focusing on the threat intelligence. Yeah, so there are multiple Chinese national authorities now working on this issue. Yeah.
Okay, we have another question from this guest.
Yeah.
What if the system, if physically hardened, like even USB or any other item cannot be attached to it, then can it still be hacked? Or can it get infected if a person is passing nearby that system? His cell phone is infected, and from there, that MPP plant system gets infected and starts behaving erratically.
So yeah, I'm not a hacker, so I think hackers always have a way. I can just imagine so the system is hardened, but the system may have backdoors, so which is rooted in the development phase of the software. So there may be some logical bomb. So if there is some condition is triggered or some time is passed, and there are also some bad things will happen. So we don't know. We don't know about that. It's just as the figure I showed. It's a game. It's a game between the adversary with our defenders. Yeah.
Okay, we have another question. How safe is it to use cell phones in MPPs?
No, don't use it.
So, like an operator or maintenance works.
No, don't use it. Don't use it. So now as I know, many nuclear facilities, they have forbidden the people using cell phone in their facility. So usually when they are entering this facility, they have to keep these cell phones at the gate. Don't bring it into the facility.
Okay, we have another question from Christopher.
Mm-hmm.
Nowadays, artificial intelligence AI is gaining grounds. Do you have any plans to use AI technology for MPPs? And what do you think its implication to computer security?
Okay, thank you, Christopher. The very good question. And yes, the artificial intelligence. In fact, the week before last week, I went to Vienna and had the technical meeting named AI application in the near term and near-term deployment of the RNC systems. So there are like 19 experts from all around the world. We are talking about how we can incorporate this AI technology into the RNC system. So my talk on that technical meeting is about how we can using the industrial AI to detect the cyber attack cyber anomaly of the RNC systems. So yeah, so if you are interested, you can write me the email.
Let's, yeah, Mr. Lee needs to drink some water. Another question, if cell phones cannot be used, how about IP phones, which are the current phone technology?
Yeah, the
IP phone.
yeah. So yeah, IP phones. Yes, I know some like the AP1000 plants. They are building the IP network. The Wi-Fi network using Wi-Fi technology, and people can use the IP phones. Yes, I think if it is can be, and also there are in China, because you know China has a 5G techniques, and 5Gs are more secure than the used, so we can build some special network like the VPN. So the special network by through these 5G techniques. So the network just only in the site of in the MPP site. So there's multiple ways. Yeah, we can discuss it. This it's just like the two double side of the coin, and we just to trade off the convenience with the risk. So yeah, so maybe some regulators say IP phone is okay, we can use it. So it's not just just a single answer. Yeah.
Thank you. Is ISP needed in this technology?
You mean yeah, it's needed. You mean in the 5G technology? Yes. Yes, in fact, there are several ways. As I know, there are several, maybe 2 or 3 Chinese MPPs are now just this year they are now building the 5G production network. So I can. I'm not sure. I'm not know the detail of this, but I just know the progress. Maybe you can find some paper or some reports on this in the near future. Yeah.
Okay. I'm afraid we only have maybe 3 minutes to give a closing remark, so no questions. On behalf of our ANANT president, as a steering committee member, I would like to give a short closing remark on today's webinar. Thank you. First, I would like to show my thanks to Dr. Lee to give such a comprehensive and detailed presentation. And we will upload the video of today's presentation maybe tomorrow. You can see it on our ANANT website, which is already shared in the chat box. You can visit the website to see more information. As we know, ANANT is an organization supported by IEA to share nuclear knowledge all over the world through many ways. This is one of our ways. And this year is the 20th anniversary of ANANT. ANANT was founded 20 years ago in 2003. So in this year, we will hold a series of webinars besides this one from many countries. The first one is China. We will have webinars from Thailand and Australia and Japan maybe, and Korea. So we look forward to share more webinars with you, and welcome to join us. I think that is all for today. And we hope to see you in the next webinar, maybe also provided by China. We will talk about the 4th generation reactor, the high temperature gas cooled reactor, which has the self-safety character, I think. We will invite a professor from INET in Tsinghua University in China to show you the situation of high temperature gas cooled reactor in China. So maybe we will see you next time. Do we have any, Helena or any officers from IEA would like to say something?
Yeah, I would like to
yes, Helena.
congratulate you all with the superb webinar, with the very great initiative. Thank you, Xiaojin. Thank you, Professor Li, for the very interesting and very useful information. Thank you.
Okay, we will look forward to seeing you again then. Bye-bye.
Bye. Thank you, everyone.
我截了一些屏。哦，还有一
Bye.
些。
Bye. Thank you.
Bye bye.
Bye.